Got to give the people la 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 la. Give the people what they want. Mr. Bass, I'm here. Arise. Kicking this new one. Let's get it. We are talking about polynomials, factors, and roots / x-intercepts. All right, so one, a root or an x-intercept mean the same thing. That is the same idea. Use them interchangeably. You can also call them solutions, but we'll probably refer to them as roots and x-intercepts. So let's focus on x-intercepts. What has to be true about all x-intercepts? You know this, but I want to make sure you remember. So go ahead and draw this polynomial over here. Draw this whole piece, okay? Draw this parabola, I should say. Let me go ahead and undo that. So you've drawn that parabola. And go ahead and label the x-intercepts for me, right? So give me the ordered pair. So cool, you gave me the ordered pair for this first x-intercept, which is what? X is 2, 0. Give me the ordered pair for this x-intercept, which is -3, 0. Okay, so this is x-intercept right here. This is root right here. Both of those mean the same thing. All right, so what has to be true about all x-intercepts? What do both of those x-intercepts have in common? Oh yeah, y, I shouldn't write it like that. Y must equal 0. For every x-intercept, y has to equal 0. And that is super important, right? Because that's how we find x-intercepts. So let's keep it moving. So go ahead and write down this problem. And what we're going to do is find the roots, aka the x-intercepts from this problem. And I'm going to tell you ahead of time how we're going to do it. We're going to take that problem and we're going to convert it into factored form, factor it. Secondly, we're going to use the factors from factored form to find the roots. And we're going to set each factor equal to 0. All right? So let's jump in here and let's make that happen. Boom, boom. Okay, so let's go ahead and factor this bad boy right here. And I'm going to do it real quick, right? So we have x minus 4 squared, boom, x squared minus 12, they have to add to -4, multiply to -12. So what is that? If this thing's going to add to -4, multiply to -12, what is that? 6 times 2? 6, 2. We need this 6 to be negative. So we end up with x. We have minus 6x and 2x. We end up with x plus 2 and x minus 6. Okay? That's the part you know. So we took this bad boy to factored form. So we end up with, we moved from here to here. Y also equals x minus 6 times x plus 2. That's what we did in class today. So that should look familiar. Okay? So now, we found factored form. The factored form is what is going to help us get the roots. Let's think about roots. What happens to all roots? We know that for all roots or all x-intercepts, y has to equal 0. So look what I'm going to do. I'm going to set y equal to 0. So 0 equals x minus 6 times x plus 2. Now let's pause here and slow down for a second. If I'm going to take this number, there are two numbers ultimately here. This number and this number. Those two numbers together multiplied equals 0. Well, the only way for that to work is either x minus 6 has to equal 0 or x plus 2 has to equal 0. One of those two things has to be true to work. All right? So how could x minus 6 equal 0? What would x have to be? Well, you probably know in your head it should equal 6, right? So let's see. If I said x equals 6 and plug that in, 0 equals 6 minus 6 times 6 plus 2, right? If x does equal 6, well, we get 0 equals 0 times 8. That's what we want. 0 times 8 equals 0. This whole equation works. Hopefully that makes sense to you. So one of my x-intercepts has to be at the point where x was equal to 6, so that y ultimately equaled 0. That is an x-intercept. But that is only one of them. How am I going to make, there's another root. There's another x-intercept. What would x have to be to make that factor equal to 0? So hopefully you're looking at it and you're like, oh yeah, well, what if x was negative 2? So cool, let's plug it in. Let's see what happens. 0 equals negative 2 minus 6 times negative 2 plus 2. Again, I'm trying to find the x values that give me a y of 0. So 0 equals, what is that? Negative 8 times 0. Oh, look, I'm good. 0 equals 0, which means that works. So what is my other x-intercept? Well, what did we plug in for x when x was negative 2? Y equals 0. That's my other root. That's my other x-intercept. So I just found the two roots. Each of these factors corresponds with a root. So if I was going to graph this parabola, I'd be like, okay, I have a root at negative 2, 0 right here. And I have a root at 1, 2, 3, 4, 5, 6. 6, 0 right here. And my parabola does something like this. Okay? So the factors, when I set them equal to 0, help me find the root. Let's move to this next page. So again, let's put a star here. So to find a root from a factor, set each factor equal to 0 and solve. So you're going to do one example. Find, that's not how you spell find. Find the roots of this quadratic. And it says 3x squared minus 11x minus 4. This quadratic right now is in standard form. Why don't you go ahead and factor this thing for me first? Okay? You paused it right here. You factored it. You did your work. If you did your work correctly, it's going to look something like this. You're like, okay, I could do this. This is 3x squared. This is minus 4. These things have to multiply. Let me see. They have to add to negative 11. Excuse me. They have to add to negative 11. And they have to multiply to whatever 3 times 4 is. What is that? Negative 12. So what is that going to be? That's going to be 12 times 1. The 12 is negative. Negative 12 times 1 is negative 12. Negative 12 plus 1 is negative 11. Cool. Negative, oops. We got negative 12x here, 1x here. We got 3x here, x here. We have 1 here, and we have negative 4 here. Everything works out. So if I put that bad boy into factored form, I'm saying this turns into y equals x minus 4 times 3x plus 1. x minus 4 times 3x plus 1. I went from standard form to factored form. Now I have to now go ahead and pause it and find the x-intercepts. Cool. Hopefully you did that and you're like, oh, okay. I'm going to take this factor and set it equal to 0. So one of these things has to be true. Either x minus 4 has to equal 0. So I get plus 4, x equals 4. So my root, aka my x-intercept, is when x is 4, y is 0. Or my other option is this factor has to equal 0. Okay, so I'm going to do 3x plus 1 equals 0. And I'll say, okay, well, minus 1, 3x equals negative 1. Divide by 3, x equals negative 1/3. So this root, or x-intercept, is x is negative 1/3, y is 0. So then if I was going to turn around and graph this thing just by the roots, and this is just a sketch, I'd be like, okay, well, I know it's a parabola. I know it's positive, so it's going upwards. So I have one root here. If this is, let's say, 1, 2, 3, 4. These are negative 1, negative 2, negative 3, negative 4. And if this is 1, 2, 3, 4. This is 1, 2, 3, and 4. I know I have one root at 4, 0. And one root at negative 1/3, which is about here, and 0. So I'd have a parabola that looks something like that. Heck of uneven, but you should get the idea. I just squeezed a whole bunch of days of work into one, but hopefully that makes what we need to do in class tomorrow that much easier. All right? Thank you all for getting the homework done. Mr. Bass, I'm Iggity out.